last week we programmed this procedurally. I went ahead and finished the program. A little hindsight bias, I probably should have assigned it as homework, but we'll go through that finished program and kind of look how we've done it procedurally. And we're going to talk about object-oriented design and programming today and how to reprogram this with object-oriented design. And then what is due for this assignment from you is to write that half-page single-spaced paragraph. I really don't mind if you space it. That just gives you a rough estimate of how much information I want from you. Okay, so if you'd rather turn it in a different format, that's okay. And you can even make it bullet points if you wanted to. All right. And then some of the questions that you could answer would be, what are the similarities and differences between procedural program and object-oriented design programming? Which programming paradigm is more efficient in program design and implementing design and then running the actual code? Okay, so you can give that some of that deep thought on that, and then we'll talk about it after you guys turn it in. So it's due Friday. I made it due Friday. All right. Going back to pages here. And I gave you guys one more assignment, but it's not due until next Tuesday. And it's making a class with objects. And we'll get more into this assignment on Thursday. We're going to do a worked example together that's similar to this. So then you'll know what you're doing and turn in the appropriate class files for this assignment. Okay, so just a couple assignments out there. All right, so let's continue on with our homework / class assignment that we've been working on. So we are programming this programming problem with acceleration. We started programming it last week, and then we ran out of time. And so I went ahead and finished it, and I thought we'd just do a rough rundown of the program. All right. I gave you guys the program that I made, and it is here in acceleration.java. Remember that when you click on this, it'll ask to open it in Eclipse, and you can open it inside of Eclipse. But when you open it in Eclipse and it's not part of a project, when I go up here to hit that green run button, you're going to get an error like this saying, hey, I don't know what kind of file this is because it's not part of a project. So if you download a file and it opens in Eclipse, it's not going to run until it's part of a project. All right? And the easiest way to make this part of a project I have found is I double click and copy this class name. You guys probably already have this class, right, on your computer. Maybe some of you already finished this. Some of you finish it on your own. No? Yes? Good. Okay. So you would just make a new project then, or add it to an old project. Okay. And then you would make a new class. This is where I do Control V and paste it. And then I just do a Control A, Control C. That means Control A selects all, Control C copy from the one I downloaded. And notice also up here, see how it's like the hollow J? See up there, the little icon? If it's a hollow J, it means, hey, I'm not part of a project, I'm not going to run right. Okay? So I just copied all this code. I come over here, and I'll leave that package thing because I need that. And then I'll do Control V as in Victor to paste that code. And voila, now it'll run in Java. Of course, I need the file, the text file, but it is now actually compiling and running and all that good stuff. All right. So you guys should have that file. And then I just need my velocities txt again. Remember to download it, save it, go to where you saved it. This should be kind of easy for you now. And then the easiest way to get into Eclipse is to have Eclipse on this side of your, or somewhere over here. open up that Package Explorer, and then just drag that text file to your project folder. I'm just dragging it from my files to my project folder. And remember that you want it in the project folder outside of the source folder, but inside of the project folder. So now that I have that text file in there, my file not found exception will not be thrown because he will find it. And so he should find it, and you can see that he finds it, finds that file, reads that file, and produces some output. So when we were programming this in class together, I think we got up to about this part. So let's just run through the rest of this code really quick. Okay. So we have our while input stream.next line. Remember that this method, what does it return? You can tell what it returns just by looking at it. What type does that method return? Has next line. I think we asked this last class. The has next line method must return starts with a B, a Boolean, right? Whenever you see a method where a Boolean statement should be, it makes sense that that method is going to return a true or a false. Okay? So you can even think, okay, this has next line method is going to return true if there's another line in my file and false otherwise. Okay? So you can tell a lot by a method just by the way it's used and by its name. And note that here in our while loop, it will keep looping while there's more lines in our file. We read in the first number in that first column with next double. We read in the second number in the second column on that same row, the same record. And we put them into our array at the same index. So we're loading our parallel arrays. Last time we looked at that picture of our parallel arrays, how we're loading them. And then we increase that index so that we don't load everything at the 0 index. So we need to increment our index in that loop so that it'll put the new data in the following indexes or indices. All right. Note that we load our array, and that's all we do in this while loop. We want to do this quickly and efficiently when you read from your hard drive, because this is the most inefficient part of our program. This is the part that takes the longest. When you're reading resources from a server or a hard drive, you want to do it fast, load it into your data structure so that it'll be more efficient. You don't want to do a lot of programming in here. You just want to get that data and put it into your data structure. Okay? And our data structure is our arrays. All right, the next steps were to make that table. So hopefully this part of our code makes sense to you. First we print our header of our table, and then we do our for loop. Note that I went ahead and made a constant. So I made them all caps there, a local constant. Remember that when you make constants in most programming language, you capitalize their names. It means that I can't change that variable's value ever, which was fine for this programming problem. This for loop loops 100 times exactly. Okay. And then it calculates my acceleration using the acceleration method from above. And we give to it as our arguments the appropriate values from our array. Okay, so notice that we're using I to loop through those values, those parallel values. So we calculate the acceleration, then we calculate our meters per second to miles per hour, and then we calculate our displacement. And remember that these functions are pretty easy, these methods. You should be able to understand them. And then the most important thing about these methods is that we had our parentheses and we weren't doing logic errors. We were doing our order of operations in the correct order. So, and these functions, of course, were given to us. Well, we had to translate them to Java, but the equations were given to us. So pretty easy to translate those. All right. And then, of course, in our for loop, we print out those values that we've just found, and it creates our table as you see it. All right. So this would be procedural programming. How do I know this is procedural programming? It's kind of blatantly procedural. Yeah, it runs from the top of main to the bottom of main, stops. There's no instance variables. Okay? The methods that I use are all static. Okay? If I have all static methods, it means I'm not being very object-oriented in my design. I have what's called no instance variables, so hopefully you got a chance to read the beginning of chapter 9. You realize what an instance variable is. All right? So it looks very procedural. Oh, it is very procedural programming. All right? So what we're going to do is we're going to look at object-oriented design now. So I went ahead and I put a link to this Prezi inside of Canvas. It's a short little Prezi, and then we're going to jump in and program this thing object-oriented, but I think it's a good idea to figure out the differences between procedural and object-oriented.
The art of object-oriented design and how it differs from procedural programming. Let's first remember the software development lifecycle. The software development lifecycle, or SDLC, is a framework defining tasks performed at each step in the software development process. So here it is pictorially, showing all of the steps. SDLC is a structure followed by a development team within the software organization. It consists of a detailed plan describing how to develop and maintain and replace specific software. The life cycle defines a methodology for improving the quality of software and the overall development process. And so when we're designing our programs and deciding if we're going to create that program with procedural programming or object-oriented programming, it happens here in the design process. And then when we implement it in our code or write our code, we would either write it according to our design, whether it be procedural programming or object-oriented. So right here is where we're focusing on. So whenever we want to write a program, it starts with an idea. Whatever that idea is. First, we create the specification, the rules of how it should work on our computers. This is the system engineering step in the SDLC. Usually this will be given to you by the engineers that are in charge of the project or by your instructor. In procedural programming, we start by thinking about what we want our program to do, what steps we need for our program, and what functions we need to write. In first level programming, this is the way that we've programmed. You know that a program is written procedurally if there are no instance variables, if the variables and methods are all static, and or if there is only a main method. Object-oriented design, on the other hand, is the process of using an object-oriented methodology to design a computing system or application. This technique enables the implementation or writing of the software solution based on the concepts of an object. Instead of just thinking about the steps to solve your problem, you first think about the objects that you're going to make to hold your data. Such as if you were writing a program about a car, you would think about what attributes does the car have? I need to know how much fuel it has, or its max speed. Then I think, well, what methods will act upon those attributes or that data? I need to refuel or get fuel. I need to set the speed or get the speed. I need to drive. So your objects will be how you represent your data in your computer. Your objects are comprised of the data that describes the object and the methods that work upon that data. So here's another example. Such as if we were making a dog object inside of a game, we want different types of dogs in our game. We don't want them all to look the same. So we would make an object of type dog. And for that dog, we describe what that dog is going to look like. inside of our computer. What color the dog would be, its eye color, its height, its length, its width, or weight. And some things we'd like the dog to do, maybe sit or lay down or shake or come. And so we'd create instances of that object in our game, such as we could have a dog called Rain. It could be gray, white, and black. It could have these property values, and it can do all of those same methods. And we could create lots of different types of dog objects, all from this same base class. So we only have to write the code once for the base class, and we can create many different types of objects in our code. So object-oriented programming versus procedural programming. Object-oriented design encapsulates the data in a single variable, which is a reference type variable. And this makes it easy to pass this variable into a function or method. In procedural programming, the data is stored in separate, unrelated variables, such as using parallel arrays. This makes it hard to write a function that uses that data because all of those data or all of those variables will have to be passed in as parameters. OOP or OOD makes the design process easier and faster. In procedural programming, design is straightforward but can become confusing because of the unrelated data. Over here, implementation is faster because of the use of reusable objects. In procedural programming, implementation is longer because there are no reusable objects. In OOP, file sizes of your code are larger because of all the extra code written for that object to represent it in the computer. Whereas in procedural programming, file sizes are kept small because you don't have all of the extra code. And lastly, in OOP or OOD, code usually runs slower because of the extra code and because references are used. Whereas in procedural programming, you get to have the most efficient code with less abstraction. So if you minimize your abstraction, you get closer to the hardware and your code becomes more efficient when it runs on the computer.
Okay, we're going to write this function and do these steps. Now we're going to think about data and how we're going to make this object. Okay, so what data do we have, hint, hint, for our that's going to describe an object inside of our program?
I have two velocities separated, well, listed velocities separated by a space and new line character.
Good. Yes, we have a list of velocities. And these velocities are associated with each other, so they are an object. Okay? If these were totally unrelated, then we wouldn't want to group them together. But they are related. This is the initial velocity. This is the final velocity. All right? So we can think of our object as an acceleration object. It's going to have an initial velocity and a final velocity describing that acceleration object. Okay? So we think, okay, we're going to make a variable or an object that has these two variables as part of that object. They are going to be its instance variables. All right? So let's start making that object. Okay, this was a radically new idea, and actually it's led to all graphical programming in the world. This is why we have such awesome programs, is because of this object-oriented design. All right, so let's make our object. You guys can work along with me if you want, but I will post this code after, so all right, so don't feel stressed out if you can't type fast enough. All right. Now I already have a class called acceleration here. So I'm going to go ahead and make a new class, and I'll call him my acceleration object. Now we're going to kind of cheat a little bit today and put our main method right inside of our class, our object class. On Thursday we'll figure out a little, or sorry, on Wednesday we'll figure out a little bit better way to program by making separate files, but today, and it's good to know both ways of doing things, but today to make it easier, we'll just put our main method in our class. Okay, so you guys can check mark that we want main in there. So since we're coming object-oriented design, we're making this, we need to make our instance variables first. So the first thing you do in object-oriented design is you think about your data, how you're going to encapsulate that data in an object, and then you make its instance variables to describe that object. Okay? So these are going to be the instance variables for every acceleration object. Okay? And we are going to make them public at first, and if you've read your textbook, you know this is probably not the, we're going to make them private afterward, but I wanted to make them public at first to see why we needed to make them private afterward. Okay? So we're going to make a public variable of type double, and the reason I chose double is because if we look at our data is in doubles. So we're going to have one instance variable describe our initial velocity and a second instance variable describe our final velocity for every object. All right. So this will be our initial velocity. And then I will make a separate instance variable to hold our final velocity. Now note, very importantly, I did not put the word static here. Okay, if I put static here, I could only make one of those variables for every object that I make, and that wouldn't be good. I need every single object to have their own initial velocity and their own final velocity. So we're going to make 100 objects now of type velocity. And each one is going to have their own initial velocity and their own final velocity. Okay? So these are our instance variables. Okay? Let's make the rest of our class. Now, when you're making an object, you need certain methods part of that object that are standard as part of that object. Every object has these. Okay? And one of the methods that we make is a special method called a constructor. Okay? And the constructor's job is to construct or build that object inside of main memory for us. We've been using constructors all along, but now we're going to make our own. Okay? Where we've used constructors, just so you know, when we make a new scanner object, this is the scanner constructor. When we made our new file object, this was the file constructor. We know it's a method because it has parentheses here. Okay? So let's make our own constructor. So construct are special methods that do not have a return type. And what's something else that you notice about this method that's different than other methods that we've made so far? It doesn't have a return type.
It's non-static.
It does not have static. It would not make sense to make this static. So don't put static, don't put a return type. And what's another thing we see special about this method? Which we always do to methods lowercase them, right? But this method has the same name as our class, and that's a rule too. So for a constructor, no return type, don't put static, and the name of your constructor is going to match the name of your class and be capitalized. It's the only method that's capitalized in Java, is our constructors. All right. Now the purpose of this constructor is to initialize our instance variables and create the object in main memory. Okay, so we need to initialize our instance variables in here. Now we can initialize our instance variables to whatever we want to initialize our variables to. So I can initialize them to 50 or 100. A lot of times we initialize them to default to 0. Now what if I wanted to initialize them to something, like I'm reading in from the file and I want to initialize them to the two values that I've just read in from the file? If I want to send a method information, what do I need? Parameters, right? I need to have a method with parameters. So let's make a second constructor, and it's common practice to make more than one constructor. So let me make this second constructor and explain it to you. All right, so now what we have two constructors. And we are allowed to do this for a couple of reasons. One, they have a different number and type of parameters. So we're allowed to have a method with the same name as long as their parameters are different. Okay? So now these are both constructors. And that constructor up there that takes in no parameters is actually given a special name. He's the default constructor. And he's considered the default constructor because he has no parameters. Okay? So you can even add that to your notes up here. We write notes in our... Remember that you can write more notes than I've written as comments inside of your code. Kind of like taking notes in class. Okay? So here we have two separate constructors. One is called the default constructor because he has nothing in his parentheses, so 0 parameters. Yes?
What does the meaning of default 0 do again?
You're just initializing that variable to something. Okay? And you can initialize it to whatever you want it to. Maybe in your program, you'll initialize all of your initial velocities to 0 and all of your final velocities to 100 because the rockets you're working with, the default is to go a final velocity of 100. Okay, so you as the programmer get to choose those default values in your constructor. But a lot of times people put 0 because it's a good way to start, good place to start. Now notice in the second constructor, we've initialized them to what we've passed in as the parameters. So in the second constructor, we passed in 2 parameters and are setting our instance variables to those values that we've passed in. Okay. Now this might be a little bit confusing at first, but as you start doing this, it does make complete sense. It's actually quite simple. Okay. So let's use our constructors and see how they work and understand them. Okay? So now we got these beautiful constructors. I come down here to main. There's nothing written in main. So what will my program do when I compile and run him? Nothing, because main said, okay, start here, end here, there we go. So even though we made those beautiful methods, we haven't used them yet. So now we need to make them. Okay? Or actually call those methods. So the way that we call them is we're going to make a new object of type acceleration object. Remember that what we already know. Okay. Remember that we've already been using objects. Okay. When we are making a new scanner object, what did we do? We declared the scanner object type scanner. And then we instantiated that scanner object with new, and then calling his constructor with the proper parameter. Okay? So when we make our acceleration object, we're going to do the same thing. We're going to make a type of variable called acceleration object. So you can copy and paste, Control C, Control V. We're going to make an acceleration object. And you can name your acceleration object whatever you want, but we do respect the standard of naming our variables with lowercase letters. Okay, so make sure you have that lowercase letter in there. And then because he's an object, we're going to instantiate him with the new operator, and we call our constructor. Do you see how this is calling that default constructor with no arguments and no parameters? He's going to match it to the default constructor. So meaning he's going to go to that default constructor, run that code, initialize those variables for us, and give back to us a reference to this new object in main memory. Okay, and we'll draw a picture of this too. Okay? All right. And let's just see what's happening here. So let's print out a couple of things so we can see what's going on. First, let's print out our object. What do you think I'll print out there? Okay, we'll talk about that. And then let's print out our object's values of his variables. Note if I put the dot operator after my new object of type acceleration object, he already has a whole bunch of methods associated with him. And he has some instance variables associated with them because we made them public. Okay? So we can print out his final velocity, and we can print out his initial velocity. And the reason that we can do this is because these guys are public instance variables. Which is, again, not the best way to program with public instance variables, but we're doing it for now to make it easy. Okay? Just to make it easy and kind of understand what's going on here. All right, so now you should be able to run your code. And actually, I erased printing out my object. I still want to print out my object.
Oh, we don't need to include anything because it's included in the main.
Yeah. So now our main will run from the top to bottom. What's it going to do? Okay, so first run it, and then we'll draw a picture of what it's doing inside of main memory. All right, see what it printed out here. It says, here's my package name acceleration, here's my class name acceleration object, an @ symbol, and then some weird hexadecimal number. Remember base 16. Right, very good. It's the memory address. So what does that tell us about this object? He's a reference variable. He's pointing to somewhere in main memory. So let's draw a picture of that. Memory. Now, a lot of times when we draw main memory, we'll draw it something that looks like this. Okay. And let's draw some more main memory over here. All right. So here's our memory locations inside of our RAM. Now, it doesn't look like much. But remember that each of these memory locations inside of your main memory can hold a value of a variable, right? They can hold data. That's what we use our main memory for. But remember, all these locations inside of your memory also have addresses so that we can find things. Just like houses have addresses so you can find somebody, right? Main memory locations inside of your computer where we're storing that data each has a memory address. Okay? And these memory addresses are ones and zeros. But a lot of times we'll show them or depict them with hexadecimal because it's easier to write than writing, 64 ones and zeros. We like just to write them in hexadecimal form. Okay, and sometimes up here I'll even shorten it even more and just write really small memory addresses. But remember that what I'm writing on the side here is representing their main memory address inside of RAM. Okay, so sometimes I just kind of cheat and make some main memory addresses that look like this. Okay? But remember that those are just main memory addresses of where we're storing our information. How many addresses does your computer have actually? You guys know?
Whatever 12 gigs is worth.
So he has 12 gigs of main memory, so his main memory would have to address 12 billion different main memory addresses. Okay. If our computers here have 4 gigs of main memory, then we have to address 4 billion main memory addresses. Okay, so remember you have this picture of main memory, we're addressing things. All right, a little abstract. Now when we create a normal type variable, I say normal, I mean primitive. If I say like int number equals 6, what does your computer do in main memory? It says, okay, I'm going to go find a main memory location where I can store an integer. An integer is 4 bytes long. So I'm going to store that I'm going to store the number 6 here. Okay. Inside of my 4 bytes of main memory. So it takes that 4 bytes of main memory and it puts the 6 in there. And then it says, okay, I'm going to call this section of my memory number. So whenever you say number in your code, it knows to come here, grab that 6, do some math with it. Come here, grab that 6, you can print it to the screen. Okay, so primitive type variables are stored at that main memory location where the variable says it.